All right, guys, welcome to Engineering for Communities live show. I'm super stoked for today's presentation. If water losses is what you're looking to alleviate, find out more information, this is the show for you. I'm going to hit play on this presentation, bring questions afterwards. All right, guys, I am here today to talk about the importance of a detailed water loss analysis, kind of how I've uncovered hidden water losses in my experience, and I wanted to start sharing some of these secrets with you. Okay, so why did I feel like this was important to share? I've been going around interviewing different water sewer providers in Colorado and Texas, and I was finding one of these was one of the common themes. And so of the 14 specifically water providers I interviewed, 50% of them mentioned that they were having issues with water losses and they didn't know the next steps to make. Okay, so why does a detailed water loss analysis matter? Water is getting more and more expensive, especially in rural Colorado. It's expensive to buy, sell, get water up there. And so that's quite a big deal. If you've got aging infrastructure and you need to identify where things need to be replaced and how to come up with a priority list. Also, that's going to tie into your typical project needs assessments, which you're going to need to get loan and grant funding for your projects. Another part is it's part of your regulatory compliance. All the states require you on some level to report on how much water did you pull out of the ground, how much did you pull out of the reservoir, how much did you sell, and how much did you lose. I think it's a long-term financial savings to the district, provider, whoever. I think that just spending less money to pump water into a system to not get to sell it just doesn't make sense to me. And then the biggest one is you want to protect your end users. So making sure that they're not getting these water outages. I hear story after story about different water providers where people go out for weeks with no water, and it's just awful. Okay, so what are the limitations of your typical reports? A lot of them are called augmentation reports. I've got an example of one right here on the left. As you can see, they total up their total water production, which goes into a water treatment plant, and then that water goes to a customer and it gets billed. They've got that line item there. They've got, the internal like flushing and water they use. That's the 450,000, and they're saying, okay, we had about 500,000 gallons this month in water losses. But what's happening is all those wells, a lot of times, are located miles, hundreds of feet away. And so you're not quantifying what actually leaves the wellhead and comes into the treatment plant and then breaking those two up. So you're not understanding what you treat versus what you pump. And then once again, not having that data, it doesn't help you decide where you should start focusing your efforts to look and try to figure out where you might have a problem by sending someone out and doing field research. And then this 1 month doesn't really show the trend. So it says that they had 27%, but it doesn't really show them like, okay, well, what was last month, the next month? How did that compare? Is it getting better or worse? So like, what do we need to do here? Okay, so here's a quick area graphic of understanding where water losses come from. So you have your point source down here. And what is that? That's your river, your well, your any of those places you're getting water from. You could be getting it from another source. So one, you'll want to know what comes out of that. So that's a number to quantify. And then you have your treatment plant where the water gets treated before it goes to the end user. And you'll want to have a meter there. Most people do. And then it goes into your distribution system here. So you see there's mains, storage tanks, and essentially then you have the lines and the homeowners, which is usually has a meter in their front yard or in a crawl space or something. It really depends on where you're at. So those are the main areas. Okay, so I want to go over a case study, something I experienced. It was a 4-year transformation of a rural community in Colorado. They had about 200 taps. There's 6 miles of main line, and they were suffering from over a 30% water loss, which is pretty substantial. And we ended up getting them down to 7%. So I want to share that story with you. Okay, so where did this community start? They were a district that originally was built by a developer who subdivided a large area, and then they sold the district for X number of $1 million. I don't have that number. And the district, they formed a metro district, and they ended up owning and managing this system. Now, they knew that they had pretty poor records on what was actually built. And what we knew is, as you can see this picture on the left here, the pipe was thin wall pipe. So this was the main pipe that they put in there. It's equivalent to like sewer line pipe thickness. And it was installed in the 80s. So they knew they had an aging, older infrastructure. Okay, so what did we know when we started the project? Well, here's a picture of something straight out of one of the water treatment buildings. These were the kind of as-builts we were working with. As you can tell, there wasn't even a scale bar on here. There's some contours. So we had these old plans we were working off of. But a big thing we knew that they had old meters that hadn't been updated. A lot of them were in the crawl spaces, in the lots, in the homes, meaning that the district was liable for everything in people's front yards. That's not something you would want to do. We knew that certain sections of the pipe would freeze during the winter, and then they would thaw during the spring. We also knew that there was a very good chance that this community would be considered disadvantaged given the proper help, and then that would get them to qualify for significant loans and grants. And then lastly, the most important part of it is they were not able to consistently keep up with their water production, meaning that the water tank would run out of water and residents would have needs for water, and they wouldn't be met by their expensive water bill they were paying for. And we kind of started thinking, oh, well, because they can't keep up with their demand, we should build more wells. So we started to budget and think about building more wells. So our first goal in year 0 to 2 was to quickly identify the problems because we didn't have very good data, and we wanted to get them in the door for certain fundings and get the water meters replaced, because if we could move the water meters from the residents' crawl spaces out towards the road, then the district could know, hey, that line in their front yard, it's broken, and we could quantify it, and then the customer would be responsible. Sometimes they would get help. And so we got rid of all those old meters. We came back with a smart metering system. So now, instead of the operator having to go up and crawl up into these spaces and go into people's houses to check how much water they use, he can just drive by with a radio and it would pick it up. They were in a more remote location. So at that time, that was the best way for them to monitor them. And before we even finished putting in these meters, we were just finding significant leaks in different service lines, and they were small ones, and we were able to fix some of them on point or identify the owner, and the demand for the water that they needed to put into the system immediately went down. And then the next phase of the project was kind of year 2 through 4, and that's where we were going to design. We were able to get funding for the engineering, so we were able to design all the main line replacement, and we were going to solicit bids, try to get a competitive low bid to replace footage, because we knew we wanted to, because we had all this old pipe, so we wanted to get rid of as much footage as possible. And we wanted to work with priority areas that affected the most users first, because we did not know what sections were broken first. And as we were digging, like stuff like this, you can see there's just there's water coming out. The expression on this guy's face is kind of funny. And we would constantly have ditches and trenches full of water. Okay, so then this is where I call well number 2, the story of well 2, which is a story I've told many times and am happy to share here. So this right here, this picture on the left, is a picture of where the well piping comes out of the casing. And this pipe had this little break here in the threading, just very small. But that small little break took this well, which per the drilling reports was the best well in the district, to being a well that was pumping out a couple gallons an hour, which is nothing. So we did have meter. So one of the lessons learned was we did have a meter installed on this well in the meter project, but the operator wasn't going down there and collecting the data at a regular interval. So we couldn't look back. Luckily, I was doing the construction field management out there. And so I was walking by one day just looking at the project, and there's just water everywhere around this well. And so I was kind of like, man, that's weird. So I got the operator. We came down and I said, can you turn this on just so I can watch the meter? And when he turned it on, I looked down to the ground and there's water bubbling up. So lo and behold, we dig it up, we find this issue, we fix it. But this taught me an important lesson. It taught me that the raw water lines can have higher priority than the main lines. They can also have leaks. So you don't only want to just focus on, okay, treatment plant sends out this much water, that's my water pumped, and then I sell this much. You could be just paying to pump water into the ground like that, like well number 2. So just something to keep in mind as we move forward into the later part of this presentation. Okay, so I want to go over the results now. So we ended up determining, because of well number 2, we ended up replacing all the raw water line, which was about a mile of raw water line between all the different wells. And we ended up not, because of the data during construction that I got, we were able to make the decision to say, hey, we don't need to spend another $50,000, which was a lot to them. That's a lot to this district, drilling and trying to get more wells, because you really don't know when you're in the mountains. You don't have aquifers you're tapping into. You're just hoping that you end up in the right kind of granite fissure formation that has water flowing through it. And so because we were able to optimize those wells, we were able to take that $50,000 and get more mainline replacement. So ultimately, we were able to replace 80% of the main system, and for what I say is 40 cents on the dollar. So why do I say that? We were able to get engineering grants and matching grants from the state, and then those were paired with loans. And so 80%, like I said, they only had to pay for every dollar the project cost. They only ended up paying 40 cents of it. And not only that, that 40 cents was lumped into a 0.25 interest rate 30-year loan. And at this time, I think inflation's between 5 or 7% right now. So they're making great money on that choice. Like I mentioned earlier, they went from 30% to 7%. And as you can see, this is an image from the high tide system we installed, which is a SCADA monitoring system for their tank. That's cloud-based, so you can literally, I can pull this image off my phone, but the water tank doesn't run out, and that's what's most important to them. Okay, so you can create different visuals that help you see your trends over time. So like, for example, here, you've got every year, you can add up all your months up and add up like this and create a good visual to see how did you guys trend over time. So for example, here, they had to pump less water, but they were selling more. So this is good. They had less losses. Then you can see over here, over time, they start having more and more. And that's what this shaded area represents, is the total volume of water being lost. And you can see right here, they had a really bad break and they had to pump a lot of water, but they weren't necessarily selling more water. Which means it wasn't a huge spike in demand. And here's kind of, this is the kind of table that can create that graph. So you can see here's each data point for pumped, sold, and then that shaded area represents these losses. There's that loss right there in 2020, and it's 46%, so it's quite a bit. So here's kind of like the raw waterline considerations. So in this case, I didn't have to go do this reporting. I sent the operator on this task. And so what he had to do each day is he had a specific raw water line that was a group of wells pumping into it. And so what he did is every day he would go in and he would start reporting essentially what we pumped, how much came into the treatment plant, because it had its own little meter, and then how much was lost out of it. So we were identify that, hey, this is above the industry standard, which, by the way, the industry standard is around 10%. And we did this over time, and it turned out that something like 30% of their total water losses was coming just from this line. And they only had one main raw water line that could provide this much water. So it was a big deal to them. So I would just suggest, if you could check your inputs over time of certain wells, that would be a good way to figure out, one, is the well producing, and two, is the line have losses, because you might need to consider working on the well. And so that would be another item to look into. All right, so that's all of it that I had. I hope it's super helpful. One of the things he would tell me, the operator at well number 2, was it's a natural spring. They have all these natural springs. I've been on a lot of job sites where I've heard that story, and we've dug, and it's like, hey, there's a leak right there. So anyway, if you guys wouldn't mind, give us a follow us on LinkedIn, Engineers for Communities. We're going to be coming out with more content like this. What do you think? What's a good topic that you'd like to hear about in the engineering world? We try to share as much information as possible and give valuable data to end users that we think can help them with just overall doing better on their projects. Didn't look like we had any questions this time, but if you do, feel free to share them, and I'll see you guys next time. Thanks.